welcome to today's session as you're all arriving. So we've got John Henderson with us today from the Environment Agency. Thank you for joining us today, John, who'll be speaking to us about environmental issues and permitting for CCS projects. So I'll hand over to John Gibbons.
I just do the usual scene setting. John, when did you think you first encountered carbon capture and storage? Permitting context or any other?
It was the clean coal consultation and setting that up in 2008-9, really around carbon capture ready, and then we were doing the permitting of Kingsnorth, if I recall, at the same time.
So you weren't involved with Peterhead, the first Peterhead project?
Not directly, no. We did talk to our colleagues in SEPA quite a lot at the time, and Longannet. Not the very first Peterhead one. No, no, that was a long time ago, wasn't it?
Yeah. So capture ready is coming round again.
It is. There's a base have a call for evidence out at the moment, so if you haven't seen it, do go and see it, and that makes proposals to remove the threshold, which is currently at 300 megawatts electrical, which is quite big, obviously, to remove the threshold altogether, actually, and to also include hydrogen ready. So that's quite an interesting proposal. We'll need to do some technical studies around that to help set parameters and guidance in due course, but that's part of the proposals. So looking forward to that.
Yes, and so I guess you haven't. The Environment Agency hasn't really permitted the plant, has it? Or how far did it get with Kingsnorth? Are you going to tell us, or is that?
Yeah, no, we had a draft permit all ready to go. And similarly, with White Rose too, we had a draft permit all ready to go. So we could have issued them, and that's the way permitting goes. You do spend a lot of work preparing a permit, and then sometimes they get pulled at the last minute, which is a great shame. So they're there. You could even ask to see them, I guess, if you were keen. Be interesting to look back and see how they looked against a current permit.
Yeah, it would be interesting, I suppose. The Kingsnorth one, relevant. Although I guess, has the law changed since then?
Oh goodness.
I was thinking an IED particularly.
Yeah, no, things have changed. You're right. The IED is new, and of course the large combustion plant breath is new. Right. They weren't there then. Yeah, so there are a few new things, and obviously thinking has moved on since then quite a bit, hasn't it?
Yeah, I suppose capture level. Yeah.
Yes. Oh, absolutely. Gosh, I don't know what we had.
Kingsnorth was only down to gas levels, perhaps initially, I think.
Yeah. I can't honestly remember. Back in the midst of.
Well, that was certainly part of the debate anyway, is whether you'd only capture the gas levels. So yes, so things have changed, but I guess you've been in there all the time, the last more than 10 years now, looking at it. So please tell us about permitting CCS plants.
Okay, so I'm John Henderson. As indicated, been working in combustion and in particular carbon capture and storage for many years. I currently lead on carbon capture and storage for the Environment Agency and other net zero technologies associated with combustion. This talk is really a general talk about environmental permitting. We'll touch on some of the details around carbon capture, storage and BAT, of course, but there is a number of general bits and bobs in here that are really not intended so much for regulators as for those who aren't accustomed with environmental permitting, to give them a clue of the process that we go through and applicants also go through. So if you are a regulator, do bear with us because there's some pretty basic stuff in here. So just to highlight, Environment Agency is just England. We have devolved administrations, each with their own regulators, and it's NRW in Wales, Northern Ireland Environment Agency, and SEPA in Scotland. We all do things slightly differently. We in England have most in common with Wales, as we will all do under the environmental permitting regulations. Scotland slightly different again, and Ireland slightly different. But all the regulators implement the Industrial Emissions Directive, and that is overseen by DEFRA, or coordinated by DEFRA, as I understand it. In England, not only are we the regulator, but there are also 350 local authorities. They do the smaller Part Bs, as they're known as. We do the higher risk Part As. Environment Agency, all about protecting people and the environment and supporting sustainable growth. Obviously, we do a lot of other things other than just permitting, flooding, and water resources and those sorts of things. But under permitting, we're implementing legislation through guidance and inspection enforcement on those. The sectors under permitting are energy from waste, water, nuclear, chemicals, mining, industrial mining, all sorts of stuff are there, mining waste. We use a risk-based approach, as it's commonly described as, and BAT kind of sets the standards for us, best available techniques. You'll hear that terms quite a lot. And we also encourage operators to be certified to third-party standards. So EPR in Wales and England, as pointed out, EPR is a kind of overarching set of regulations, and it implements the Industrial Emissions Directive specifically, but also Medium Combustion Plant Directive, Landfill Directive, other directives. It can also implement parts of directives, for example, Article 15 of the Energy Efficiency Directive, that's CHP ready, so we implement that, and domestic legislation, specifically one that I'm interested in, specified generators. Those are diesel engines. There we have a schedule for that. So from a practical point of view, it's quite easy to slot in new requirements into EPR. That's the way it's designed. It includes generic requirements for permitting, inspection, review, public participation, enforcement, charging, you name it, it's all there. So it's all should be there. So it is quite easy to slot in new requirements. There are certain must-dos that are relevant for combustion. We have to implement what are known as Chapter 3 IED, and that's the old large combustion plant directive emission limit values, and each sector has its own BAT reference document. These are like holistic environmental performance standards, came from the Seville process, and they address environmental impacts, and theoretically are considered cost and benefit too. Permitting of net zero. Obviously, we're doing carbon capture and storage today, but there's also blue and green hydrogen we'll have to permit, and the combustion of hydrogen under carbon capture. We're talking pre and post combustion, oxy-fuel, alum cycle, maybe other permutations around those. The industries are all the big ones that need to be decarbonized. So we're talking power, refineries, energy from waste, cement, iron and steel. There'll be others. As you're probably quite aware, these are all new technologies, not a lot of it out there at the moment. So they're not actually addressed under any breath. There are no existing standards that address carbon capture and storage or any of these other technologies yet. We're currently working on BAT guides. There's one that's just been issued, which there's the one we're talking about today, post-combustion capture. Was issued in July. Talk a little bit more about that in a minute, but we're also working on one for blue hydrogen, natural gas and refinery fuel gas with CO2 capture. That's due out in September, and who knows, you might even get a presentation on that one day. So a little bit about a BAC guidance. Now, they're slightly different to a BREF. They're there where there is no BREF. And this is where essentially the regulator, following Industrial Emissions Directive, Article 14.6, and we set permit conditions, generally speaking, in discussion with operators. BAC guides will publish them, and they're there to assist applicants and regulators in the permitting process, also to inform the public where they're interested. It will summarize the evidence available on those emerging techniques, following what's known as Annex 3 in the IED, which is a long list of criteria. A little bit more about that. We consult with industry, and we agree these across the UK regulators, so they are in theory applicable across the UK. What they do is identify key environmental issues to address and best available techniques. They're not a regulatory requirement. If you as an operator have a better proposal and are happy to justify it, then we'll certainly look at that. But it's a good idea to follow these guides, I think would be our advice. Whatever happens, the environment is protected. Article 18 requires us to ensure that permitted processes meet environmental quality standards, and there are standards already out there for SOx and NOx, similarly for water and land, and we also derive standards, what are known as environmental assessment levels for other substances. Talk a little bit more about that in a minute. So the criteria, well, a lot of stuff here. Obviously, don't intend you to read it to you all, but it gives you a flavor of all the things that were considered looking at CCS. So obviously, we start with emissions to air, land, and water, and minimization of waste. Those are fundamental to the environmental performance. Abatement techniques and minimization techniques to derive those. Monitoring, very important for emissions. Modeling, we'll certainly be talking about air dispersion modeling and ambient deposition later. Noise, odor, both of those are addressed under permitting. Maximizing energy efficiency, absolutely. Energy is part of the process, it's resource, so we have to make sure that it is maximized or not wasted, certainly. Heat integration, important part of the process. Water use, cooling, CO2 capture, clearly an important part for CCS, the efficiency, optimization of raw materials, quality of the CO2 captured. It's got to be fit for purpose. Startup and shutdown, always important with processes. There's different emissions, different things happen during startup and shutdown. Other abnormal operating conditions, there may be some. Accidental releases and containment arrangements, that's part of that. And future-proofing, quite clearly, building on a floodplain without suitable protection wouldn't be bright. Similarly, ambient temperatures are quite likely to rise, so you've got to make yourself resilient to that. And indeed, if you're counting on cooling water, that may not necessarily be available in 10, 20 years. So worth thinking about in terms of that. So as I say, July, we issued these. There are two documents. One is the evidence document, which was put together by John and the UKCCSRC, a collection of evidence. We're talking about new build and retrofit, amine capture, based technologies, and it's for both power and CHP, and the fuels are natural gas and biomass. As I say, it's an emerging technology. And then we on gov.uk have published the summary guidance, a shorter document which has the key features in. That is the back guide we've just been talking about. So here is a picture then of post-combustion capture. I'm sure if you've been attending these, you'll probably have seen this one or one similar to this. So it's a schematic of what goes on in the process. On the left-hand side, we have the power plant or the flue gas as it arrives from the source. Goes through some cooling, important that the flue gas isn't too hot, otherwise it degrades the solvent. Then goes into an absorbing column, which has the amine solvents in, a reaction, acid-base reaction, CO2 absorbed into the amine solution. And rich amine then will go out the bottom into a stripper column, the smaller column there, where steam is passed through, removing the CO2, which is not very tightly bound to the amine. The CO2 will go to the top of the column, you can see there, where it will be dried and cleaned up and compressed, ready for sequestering and off out of the installation. On the bottom right, we have what's known as the reclaiming process. Again, we'll talk a little bit more about that. It's important that you maintain your solvent. Solvents do degrade over time and under certain circumstances, and the greater the degradation of the solvent, generally speaking, the poorer the environmental performance will be, both in terms of emissions to the environment and capture and energy efficiency likely. So you've got to maintain your solvent, and that is done generally through a reboiler or maybe an ion exchange. There'll be different processes. Could be a batch process, could be continuous process, but a proportion of your solvent will always be going through some reclaiming. So the emissions then to the environment, the key bit, or one of the key bits we're interested in, come off the top of the absorber stack, and they will be anything that's not been absorbed in the flue gas. So it could be some NOx, maybe a nitrogen, certainly, maybe a little bit of CO2, but there'll also be volatiles of the solvent, which may be amines, and indeed any degradation products that are volatile. We also may get in the stack not only volatile proportion, but there may be aerosols formed, and we'll talk a little bit about aerosols shortly. So here's a picture of one that was in the UK a few years ago. It was a pilot plant at Ferrybridge coal plant, been and gone now, but nevertheless, it was a good pilot plant. And you can see there quite clearly the larger absorber column and the smaller stripper column. This one did about 100 tons of CO2 a day, was only about 1% of the flue gas, and was post the flue gas desulfurization, so the SO2 was minimized. However, there was NOx in the flue gas, so that did cause some interesting things. Trial ran for about 18 months. Here's one we permitted about July, not long ago. This is a carbon capture and utilization plant. It's tartar salt, and this is where they're capturing the CO2 for use to make sodium carbonate. Again, quite recognizable, the larger column is the absorber column. You can see the stack at the top there with the sampling platform. That's very important. It's quite a long stack. That's to allow isokinetic flow sampling to be made to make sure that we get the aerosol proportion as well as the volatile proportion of any emissions. Then in front of it, you can see the shorter stripper stack. And the building to the left is where the reclaiming goes on and control process. And then in the background, you can see the stack, which is the combined heat and power plant where the flue gas come from. It's about 15% of the flue gas, as I understand it. It's about 100 megawatt plant there. And again, they're capturing about 100 tons a day using MEA, a benign solvent, relatively benign solvent, 35% in water. There's some of the technical details for you. So it's up and running, we hope, at the end of August, and we're looking forward to seeing how it performs. So a summary of what's in the back guide. We'll talk a little bit about the detail as we go on, but the plant should be designed for at least 95% capture of CO2. The CO2 should be fit for purpose. In other words, it should meet specification, for example, for natural grid, have a specification for putting CO2 in their pipelines. So that would be one that might need to be met. This should be designed, if it's power, particularly for flexible operations. So we're supporting renewable generation. So there will be a degree of up and down, off and on. It is also a good idea to pilot plant the solvent of choice on your flue gas. So, and that's ideally for a year if you can, so that we know what impurities may be formed and how it'll perform and how to design the abatement and so on. Obviously, emissions to air, land and water. Let's talk a little bit about air then. So what comes out the top of the stack will be some of the amine solvents, but also degradation products. And amines can degrade depending on what amine they are. They will degrade into different things, and some will degrade more than others. Particularly secondary amines tend to degrade into nitrosamines. Nitrosamines are hazardous to human health, potential carcinogen. So we have identified an environmental assessment level, which you can, as you can see, is very low, 0.2 nanograms per meter cubed. And any modeling that you do must demonstrate that that limit over a year is not exceeded at any sensitive receptor, i.e. a human habitation. Also BAT, energy efficiency, very important. We're talking about combustion here and generating energy, so we must maximize the electrical output and minimize the energy penalty of the process. So we're talking about maximizing heat integration across the process. Where there's waste heat, it should be recovered and utilized across the process. So that is part of the permitting, and we will assess that to make sure no waste heat. Cooling, we have existing guidance for that. So you will need cooling. Guidance says if you can and where it's available, use once through cooling. That's far more efficient than, for example, air cooling. So you should avoid using that if you can, but there are different types of cooling in between, and all have advantages and disadvantages. Monitoring, again, that's a key part of any process, both the process monitoring and the stack monitoring. Process monitoring, important to demonstrate you're looking after your solvent and you're capturing what you hope you will be capturing. So this is a very busy picture. You'll find it in the guidance but it's one that John's put together, which kind of takes you through the choices you've got to make in selecting your solvent. So an operator will select a solvent. There are a number of solvents out there, some proprietary, some more well-known like MEA, and these solvents will each have their benefits and disbenefits. The newer solvents tend to be more more energy efficient, and that, or at least that's the recommendation by the those who are selling them, and so have some important advantages there. But also, as mentioned, there's quite possible that they may have more harmful emissions to the environment. Emissions can always be abated. We'll talk about that in a second. So having chosen your solvent, pilot planted it, hopefully. Then you've got to look after that solvent, and that's B. We're talking about managing the solvent. So part of that process is making sure the flue gas is clean, but when it arrives at the capture stage, so that we're not got impurities reacting with those solvents. NOx can be a problem, SOx can be a problem. There may be others that cause a problem. That's why you're doing the pilot planting. You've got to make sure you're looking after your temperatures. Too hot and you may break it down your solvent. Oxygen, not so good either. And the reclaiming part, we've discussed reclaiming. You've got to make sure you maintain the quality of your capture solvent. So having done your capture, then you've got your abatement. And as said, you can always abate stuff. It's just how much abatement you require. Water washes, acid washes are all plausible, removing droplets so that you're minimizing any aerosol formation. All of that is possible. And then when you finally get to dispersion, well, you may need to reheat your flue gas to make sure you get good dispersion. Depends what condition it's in. So there's all sorts of things to think about there. That's kind of an optimization process. So a couple of extras, as it were, that need to be considered when we're talking about permitting carbon capture and storage. There is public participation, which is part of the regulations, and this really requires that the public are given an opportunity to have an input to the process. The way we do that, it happens perhaps differently across Europe, but the way we do that is when the applicant makes an application, it goes on the public register and is consulted on, advertised, and there's a month process where we will accept comments from the public and other stakeholders like the HSE, the local authority, and others who may be interested in this. All these comments will be addressed in our determination and included in a decision document, which is also available in the public domain. For sites of high public interest, we will also consult on the draft permit and the decision document. So there's a second bite at the cherry, as it were, for the public after that. Sites of high public interest, they tend to be things like energy from waste plant or maybe fracking. They are the ones that get the public most interested at the moment. Not sure if carbon capture or net zero technologies will fit into this category, but we'll wait and see. Also, as well as the application and the determination process being in public, the permit will subsequently go onto the public register. All monitoring reporting will go on the public register, and any enforcement. So it's all in the public domain. Now, there is a commercial industrial confidence process where applicants may make claims to keep things off the public register and out of the public domain. It's a set of procedures we follow. We make a determination around that. Operators must make a demonstration around it, in that their IP may be lost and they may be financially disadvantaged. However, if they're trying to keep emissions to the environment off the public, out of the public domain, that's very unlikely to be granted CIC. We are required to make sure that's in the public domain. And similarly, as the solvent composition relates to emissions, in other words, if you've got an amine there of a particular concentration, it's the one that's most likely to be emitted, that is quite likely to be in the public domain too. But these are all site-specific individual determinations. So this is just general advice, as it were. So we've talked a little bit about environment assessment levels and modeling too. So let's let's just look at that a little bit more. We have a risk assessment method known as H1, which takes operators through how you do your modeling, or it recommends how it can be done. And as I said, it's against environmental assessment levels. Environmental assessment levels are health-based exposure limits based on chemical toxicity. We'll do a study, review of evidence, put that together, run it past Public Health England, and then consult on it. We've just published 2 quite recently, MEA, monoethanolamine, and nitrosamine, both of which are entirely relevant to this process. Where there is no environmental assessment level, the applicant is required to make proposals. So if they're emitting a different amine, a new amine, for example, they'll have to make a proposal based around their own assessment of that health exposure limits and so on, and justify it, and we'll assess it, and maybe we'll accept it, or maybe we won't. So that's part of the process. So dispersion modeling, there's several models out there, and we don't actually pick a model, but any operator can pick them. But what you have to do is you have to model air dispersion modeling of the amines concentration at the top of the stack, and any degradation products from the top of the stack, and they're modeled to see what the concentration will be at sensitive receptors on the ground. Now, not only do we have the emissions from the air directly at the stack, but we also have the potential of atmospheric chemistry, reactions with amines and degradation products with ambient NOx and hydroxyl radicals can result in different substances forming, and again, there is a model available to do that. So altogether, it's quite a complicated process for both the operators and us. But long and the short of it is, having done your modeling, and we've assessed it and agreed it, and there is no harm at the receptors, you can work that back to the top of the stack, which will give you a concentration, and that sets the environmental emission limit value at the top of the stack and the monitoring conditions. So that's the process we go through, and the operators too. So what's next for permitting then? Well, we can certainly have improved atmospheric chemistry modeling of those amines. We need some further work done on that, better models. We also need monitoring methods. A lot of this is new technology, not been deployed, and so we need to have standards that operators can use routinely, and that's both for stack monitoring and for ambient monitoring. We're talking about new substances, some of them quite low detection limits, so there will be new methods required. As already implied, we will need to develop more environmental assessment levels for different solvents, different degradation products, so that's going to happen over time. One of the things we haven't considered in detail yet are clusters and multiple sources of amines, and the potential environmental fate of large amounts of amines potentially in the environment. So that's something that will need to be studied in due course. Clearly, we're going to need to produce more back guides on different net zero technologies and other priorities. So, any other questions?